Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope you all fine. Dear students, this lecture is for grade 10, subject chemistry, chapter number 16, chemical industries. This is my 34th lecture, and I am your lecturer, Mrs. Saira Jamal. Dear students, in this lecture, I'm going to talk about the urea. What is urea? Urea is a nitrogenous fertilizer. It consists of 46.6% nitrogen. It is white crystalline compound, highly soluble in water, and it is used for the manufacture of many important chemicals. But its major use is, or its major role is, it is used as a fertilizer. What are fertilizers? The compounds which are put into the soil to provide elements essential for plants' life, or the elements which are important for the growth of plants. They are added to the soil to make up the deficiency caused by previous crops. Because if we will use the same land for cultivation again and again, then what will happen? Deficiency of nutrients or essential elements in that soil will take place. So it is important to use fertilizer to maintain those essential elements in soil after uh, repeated cultivation. Types of fertilizers. There are two types of fertilizers: natural fertilizers or manures derived from animals and human waste, and synthetic fertilizers, which are man-made inorganic compounds, for example, urea, ammonium sulfate, ammonium phosphate, superphosphate, and diammonium phosphate. These are the different types of synthetic fertilizers which we prepare synthetically. You can see the first image, that which contain the natural fertilizer, and the second one where we use the synthetic fertilizer, and these fertilizers contain important nutrients or elements which are required for the plant growth. Why is urea widely used fertilizer? Urea is widely used fertilizer, like mostly we are using urea as a fertilizer instead of using the other fertilizer. The reason is that urea has the following properties or following qualities. First one, percentage of nitrogen is highest among all the synthetic nitrogen fertilizers. In urea, the percentage of nitrogen is 46%. It does not affect the texture of the soil. The texture of the soil remains same. In the soil, it hydrolyzes quickly to ammonium carbamate, which eventually changes into ammonia, which decomposes into nitrogen and hydrogen. Nitrogen is the main constituent of protein, and it is required by the stems and leaves during the early stages of the plant development. It imparts green color to the leaves and increases the yield and quality of the crop. So to increase the yield and quality of crop, we use the urea as a fertilizer, and it first it dissolve in water, and after dissolving in water, it hydrolyzes into ammonium carbamate, and then ammonium carbamate converted into ammonia. Ammonia then further decomposes into nitrogen and hydrogen, and nitrogen is the main element or constituent of protein. It is required by the stem and leaves during the early stages of the plant development, and also it gives green color to the leaves and increases the yield and quality of the crop. The comparison is between the natural fertilizer, which are also called organic fertilizers, and inorganic fertilizer, which are called synthetic fertilizer. Organic fertilizer or natural fertilizers are cheap, while the synthetic fertilizers are expensive. The natural fertilizer improves soil structure and texture, and the synthetic fertilizer, they has no fixed shape. Absorbs and hold water. They do not absorb. They cannot absorb or hold water. Not easy to control the amount of nutrients added. Easy to control amount of specific nutrients added. Help check soil erosion. Do not help check soil erosion. So natural fertilizers are better than the synthetic fertilizer due to these important qualities. How urea can be manufactured? Urea can be manufactured by using raw materials like ammonia and carbon dioxide. Manufacture of urea consists of the following steps. The first step is reaction between ammonia and carbon dioxide to form ammonia carbamate. Ammonia reacts with carbon dioxide to form ammonia carbamate and water. Then distillation of ammonium carbamate will take place. After distillation, ammonium carbamate is decomposed into urea and water. In other words, you can say that the solution of urea, then evaporation of that liquid urea will takes place, and then it's passed to the granulation tower where granules of this solid urea is formed. The urea solution is concentrated in vacuum evaporator where all the water will evaporate out. It is then rapidly cooled and sent to a tower called prelling tower. Urea prel residues are packed and then marketed. So the solution of urea is after passing through the evaporator, all the water will evaporate out. The urea will left behind. That urea is then cooled and passed to the prelling where prel or grains of urea are formed, and then they are stored and marketed. In this image, you can see the flow sheet diagram of urea cycle. Carbon dioxide react with ammonia in reaction chamber, and then in reaction chamber they will form ammonium carbamate. Ammonium carbamate then pass through the distillation chamber. In distillation chamber, what will happen? The unreacted carbon dioxide, ammonia, and water will go back to the reaction chamber. They will go back to the reaction chamber, and the one which react together to form ammonium carbamate, that ammonia carbamate is then passed through evaporator because it is in the liquid form. It is passed through the distillation of ammonium carbamate will give urea. The unreacted ammonia, carbon dioxide, and water will go back to the reaction chamber, while the urea, which is in the liquid form or in the solution form, is passed to evaporator, where hot air is passed through the evaporator and all the water will evaporate out, leaving behind the solid urea. That urea is cooled down and passed through the granulator, where granules of urea are formed and then they are stored and marketed. So steam is passed into the distillation unit while hot air is passed through the evaporator. It is mistakenly mentioned here. It must be under the distillation unit. Steam is under the distillation unit and this hot air is under the evaporator. In this image, you can also see that carbon dioxide and ammonia, they react in this reaction chamber and then they form ammonium carbamate. This ammonium carbamate after distillation is converted into liquid urea. That liquid urea is then passed to the evaporator, and in evaporator what will happen? All the water will evaporate out. After evaporation of the water, the solid urea is passed to the granulator where granules of urea are formed. Percentage of nitrogen in various fertilizer. As I told you, we mostly use urea fertilizer because it contains highest percentage of nitrogen and it is 46.6%. Some other important fertilizers are ammonium nitrate and ammonium sulfate. Ammonium nitrate contains 21.2% nitrogen, while ammonium sulfate and ammonium nitrate contain 35% nitrogen. So highest percentage is present in urea, that is 46.6%. That's why we mostly use urea as a fertilizer. Petroleum. What are petroleum? The name petroleum is derived from Latin word petra means rock and oleum means oil. So it is also called crude oil. Petroleum and crude oil are thick, dark, liquid, and they are composed of many hydrocarbons. Means petroleum is made up of hydrocarbons, carbon and hydrogen containing compounds. Fraction distillation of petroleum, the conversion of crude oil into useful product is called refining. These useful products are called fractions. Each fraction consists of a mixture of hydrocarbon which boils in a certain range of temperature. Petroleum is refined by fractional distillation in a tall tower which is called fractionating tower. The crude petroleum is or oil is heated at 400 degrees centigrade. So those liquid which has a low boiling point, they will evaporate out of promoting into vapors in the into the last or bottom column, and then compound which have lowest boiling point condense last near the top. Compound which do not boil, they will collect as a residue at the bottom. In this way, vapor condenses gradually at different level according to their boiling point. Therefore, crude oil is separated into various fractions. Each fraction has its own specific boiling range and compounds. In this image, you can see that there are different fractions or columns. The first one, bitumen, which contain the residue, the unburned compound. Then we have fuel oil. Fuel oil has highest boiling point. The lowest one is of the LPG or refinery gases. Then petrol, then naphtha. They have less boiling point. So that's why they will evaporate out soon and go to the top column. And this is the furnace where these crude oil is heated to make its different fragments or fraction. And I told you the fraction which has lowest boiling point, it will go to the top fraction, then second fraction, third, so on and so forth. And what are their uses where we use these fractions? The first fraction is liquefied petroleum gas, which is also called LPG. LPG means liquefied petroleum gas. Number of carbon atoms per molecule, they contain 1 to 4 carbon atoms, and their boiling point is below 20 degrees centigrade. So the fraction which we collected first is LPG or liquefied petroleum gases. They have boiling point less than 20, and their important use is we use these LPG cylinder for cooking, also for running automobile in form of the uh, compressed gases, but mostly we use the LPG as a gas for cooking. Petrol, which is also called gasoline, petrol or gasoline contain 5 to 10 carbon atoms, and their boiling point is from 35 to 70 degrees centigrade. And we use petrol in fuel for motor cars and vehicles. Then naphtha contain 8 to 12 carbon atoms, and their boiling point is 70 to 120 degrees centigrade. Fuel jet for jet planes, fuel for heating, lighting, and cooking all comes from the from this kerosene. Then diesel contain 14 to 20 carbon 20 number of carbon atoms, and their boiling point is 270 to 340 degrees centigrade, and we mostly use the diesel for buses, truck, and trains. Lubricating oils, which lubricate our machines and prevent them from corrosion. So, lubricating oil contain 20 to 50 carbon atoms, and the boiling point is 350 to 500 degrees centigrade. So, lubricant for machine and engines, waxes, and polishes all are made up of lubricating oil. Then fuel oil, it contains 50 to 70 carbon atoms, and boiling point is 500 to 600 degrees centigrade. Fuel for power station, factories, and ships are fuel oil. Then bitumen, more than in bitumen, we have the carbon atom. In case of the bitumen, they contain the highest number of carbon atoms. They contain more than 70 carbon atoms, and boiling point is the highest one, that is more than 500 degrees centigrade. And this bitumen we mostly use for making roads and making roof. The black color uh, compound which we use for making road and making the roofs of our houses they are made up of um, the bitumen, which contain more than 70 carbon atoms. So these are the fractions of petroleum, and the importance of these petroleum, as I told you that these fractions are used in the first one, which is the refinery gases, which are also called LPG, liquefied petroleum gases. They are used in bottled for cooking purposes. Then second one, petrol or gasoline, boiling point 70 degrees centigrade, is used as a petrol for cars. Then naphtha, which is 120 degrees centigrade, used in making chemicals. Kerosene is used as a fuel for flying aeroplanes. And then diesel is used for big automobiles, the trucks, buses, big truck and big buses. They use diesel as a fuel. Then lubricating oil to make the machine parts oily or prevent them from corrosion or friction. We use lubricating oils. Lubricating oils and waxes and polishes are used. Then fuel oil is used for ships, factories, and central heating. Like for more advanced work, or heavy machinery like ships, factories, to run factories, we use fuel oil. And bitumen, I told you, is used for making roads and roof, for making road and roofs. So this is all about the fractional distillation or important fraction of petroleum. So dear students, hope you understand this lecture. Inshallah, the exercise of this chapter is left. That exercise we will discuss in our next lecture. So in this lecture, we discussed about the urea as a fertilizer, and then how can we types of fertilizer. Then how can we prepare urea fertilizer. Also, we discussed the types of fertilizers and why we mostly use urea as a fertilizer. Mostly we use urea as a fertilizer. I told you that it contains the highest percentage of nitrogen. That's why we mostly use urea as a fertilizer. Then we discussed the synthetic fertilizer versus the natural fertilizer, and I told you natural fertilizer are better than the synthetic fertilizers. And we also discussed some of the reasons that why natural fertilizers are better than the synthetic fertilizer. Then manufacture of urea, we discussed the raw material, then the steps which are involved in the reaction. After that, we discussed about the flow sheet, diagram of the urea manufacture, which is very important. Then we discuss an image of the apparatus used for the manufacture of urea. Then we discuss the percentage of different fertilizer, that is ammonium sulfate, ammonium nitrate, and urea. And it is clear from the table that the percentage of uh, nitrogen in urea is the highest one. It is 46.6% nitrogen is present in urea, while in other fertilizers they contain 21.2% in case of ammonium sulfate, and 35% in case of ammonium nitrate. So as urea contains the highest percentage of nitrogen, so mostly we use the urea as a fertilizer, because I told you that the mm, the this urea which contain nitrogen, this nitrogen is important for the growth of plant in their early time, or in the starting time. Plant need nitrogen, and that nitrogen is provided by the fertilizer urea. Urea actually provide fertilizer or the nitrogen to the plants. Then fraction distillation of petroleum, important fraction of petroleum. Distillation, is a process by which different fraction of a liquid can be separated by difference in their boiling point. So same is here, different fractions of petroleum can be separated out by using distillation process, and as different fractions are get, so it is also called fractional distillation of petroleum. And the different fractions which we obtain from the fractional distillation of petroleum after reheating in a furnace of temperature 400 degrees centigrade and high pressure. What will happen? These fractions will go to different fractions which are present in the fractionating tower. So the I told you the one which has lowest number of carbon atom, that is liquefied petroleum gas. Their boiling point is very low, below 20 degrees centigrade. So they will collect first at the top of the fractionating tower. At the top of fractionating tower, we will collect this liquefied petroleum gas. Then the second fraction is that is petrol or gasoline. It contains 5 to 10 carbon atoms, and the boiling point is 35 to 70. Then we have naphtha. It has 8 to 12 carbon atoms, and boiling point is 70 to 120. Then same like kerosene, diesel, lubricating oil, fuel cell, and bitumen, and their carbon numbers are mentioned here. Then their boiling point, and the last one is their important uses. So I told you that LPG is used for cooking, then petrol is used as a fuel for motor cars and vehicle, then naphtha is used for making chemicals, making drugs, making plastic and some other chemicals. Kerosene is used as a fuel for jet plane, fuel for heating, lighting, and cooking. Diesel is used for big automobiles like buses, truck, and trains as a fuel, and lubricating oil for machines, engines, waxes, and for polishes we use lubricating oil. Fuel oil is used for power station, running factories, and running ship. Bitumen is used for making roads and making roofing of our houses. So this is all about the urea, petroleum, fertilizers, etc. Hope you will understand this lecture. Inshallah, in the next lecture we will discuss the exercise of this chapter. Till then, take care. Allah.